we present a stable diffusion-based approach for human de-occlusion from a single RGB image and its modal mask. Our goal is to reconstruct occluded regions and their appearance, and to output an modal mask and a de-occluded image. Previous diffusion-based de-occlusion methods struggle with two issues. First, they lack a human body prior, so the results miss limbs or produce anatomically inconsistent shapes. Second, by denoising in latent space before decoding to pixels, they often blur details and even erase visible regions of the input image. We address these issues with a two-stage framework built on 4 key ideas. Stage 1 completes the modal mask using a mask completion network guided by 2 cues, a diffusion-based human body prior and an occluded joint heat map. In Stage 2, the RGB completion network takes the predicted modal mask as additional input. We encode human semantics via a human-specific text feature and fine-tune the decoder to minimize information loss. Like the diffusion prior, the diffusion-based human body prior uses a single denoising step. It uses pose features instead of text embeddings and includes a 2D heat map-based control. We freeze this process. Using this prior, the mask completion UNet predicts the modal mask, but it is insufficient under heavy occlusions. To provide a more explicit prior, we introduce an occluded joint heat map as a cue for occluded regions, improving performance on those areas. After recovering occluded regions, the RGB completion network reconstructs their appearance. Existing methods without an modal mask often miss occluded pixels. To address this, we inject the predicted modal mask into the denoising UNet via ControlNet. High-quality conditioning is important for RGB completion. Previous methods use clip features from the image or a generic text prompt, but both lack human-specific semantics due to background leakage and coarse guidance. We use VQA to ask fixed questions on gender, pose, and appearance, aggregate the answers into one description. The clip encoder then encodes it as a human-specific text feature for diffusion conditioning. Latent representations often lose fine-grained details, even when regions are visible. We fine-tune the decoder to the input image, minimizing reconstruction error on visible regions to preserve pixel-level detail. Our method outperforms existing de-occlusion methods on both mask and RGB completion. By leveraging a human-specific prior for mask completion, it reconstructs occluded regions more accurately. Decoder fine-tuning preserves fine-grained details, producing sharper textures with fewer artifacts. The code and model will be available for research. Thank you for watching.